Okay, so we started off the year by solving systems of equations, and these were all linear. But now that we've been working with some quadratics using parabolas, we now can come up with solutions of these as well. So what we're going to do, I want to first of all just kind of talk about what it would look like whenever you graph it. So you can have two equations by one being linear and one being a quadratic or a parabola. Also, what can happen is you might have two parabolas. So for example, you might have these two, which will also give you no solution. Okay, you could have something like this, which you would have one solution, or you could have something like this, which would give you two solutions. Okay, so if you had two parabolas, that's how that would look as far as your solutions go. So you'd find their intersections just like you did whenever they were linear. Okay, but moving on, we're going to start by doing substitution, okay, and trying to solve this system. And so I'm noticing I do have a parabola and a line. So what I'm going to do is I'm going to go ahead and put in this piece for the y, because it's already in y equals form for us. So I'm going to have 2x plus x squared minus 2x minus 1 equals negative 1. So notice this piece just came from our first equation, okay? So when I combine like terms, what I'll have left then is just x squared minus 1 equals negative 1, okay? So I need to solve that. If I add the 1 over, I get x squared equals 0. And to solve for x, I'll square root. Well, that's just 0. Okay? So we have a solution at 0, comma something. All right. So now I need to plug in the 0 for my x, but I need to go back to that first equation and plug in 0. So I have y equals 0 squared minus 2 times 0 minus 1. Okay, so that's going to give me, all of that is going to be 0. So y equals negative 1. So we do have a solution at 0, comma, negative 1. So we are going to continue solving using substitution. What I think would be the best thing to do is to solve for y here. So I'll have y equals 5 minus 2x. Okay. All of that needs to go in for this y. Okay, we're substituting it in. So we'll have x squared plus 3x plus 5 minus 2x equals 0. So all of this came from that y earlier. We plugged it in for y. So when I combine like terms then, I'll have x squared plus x plus 5 equals 0. Okay, so I'm left with a quadratic. Well, it's a good thing you know how to solve quadratics. All right. You can't use factoring for this one or the square root method, so you'll have to go for the completing the square or quadratic formula. I would not recommend completing the square because this term in the middle is not even, because remember, you're going to have to divide that by 2. So I would not do that. I would go ahead and use quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so if I start plugging in my a and my b and my c, I have negative 1 plus or minus 1 squared minus 4 times 1 times 5 all over 2a, all over 2 times 1. So we need to simplify this a little bit. Negative 1 plus or minus 1 minus, I'm going to multiply all of that, and I get 4 times 1 is 4 times 5 is 20. 1 minus 20 all over 2. Alrighty then. So I'm going to have negative 1 plus or minus the square root of negative 19 all over 2. All right, well, x is giving us an imaginary number, okay? And if we have an imaginary number, it is not actually intersecting in our regular coordinate plane. It's intersecting in an imaginary plane. So there is no solution for this, okay? So if you get an imaginary number, which this has an I, right? If you were to take it out, you'd have negative 1 plus or minus I square root of 19 all over 2. Yeah, no solution. All right, and so the next one we have is here. Again, we're going to use substitution in order to solve. So you can decide which one you would like to solve for y. I'm going to go ahead and use the top one and just move everything over. So I have y equals, and I'm going to leave the 4x squared, move the 16x over, and that's now going to be negative 16x. Move the negative 22 over, and to do that, I have to add 22 on both sides. Okay. Now all of this needs to be replaced here. Okay, so we're going to replace it. We have 4x squared minus 24x plus 26 plus 4x squared minus 16x plus 22 equals 0. All right. So at this point, I would combine like terms. So I have 8x squared, negative 24 and negative 16, we get negative 40x. And then 26 and 22, we get 48 equals 0. Okay, at this point, make it easier on yourself. There's a common factor across the board of 8. So I would divide out an 8, okay? And what you'll have then is x squared minus 5x plus 6 equals 0. Okay? Let's see. If we do a times c, 1 times 6, I get 6. Looking for factors of 6 that have a sum of negative 5. Well, negative 1 and negative 6 make negative 7, so it's not going to work. But negative 2 and negative 3 would work. So I'm going to solve this by factoring. X squared, change the negative 5x to negative 2x and negative 3x, plus 6 equals 0. And then let's group them. So I take out an x here, and I'm left with x minus 2. Take out a negative 3 here. I'm left with x minus 2. And my final factored version would be x minus 2 that they both have, leaving us with x minus 3 equals 0. Now, in order to find the actual solution for x, we have to set each one of these equal to 0. So, if I add 2 over, I get x equals 2. If I add 3 over, I get x equals 3. So what it looks like then is that these two quadratics are going to have two solutions. They're going to cross 2 times. They're going to intersect 2 times. So what I'm going to do is I'm going to take the equation that I reset up myself with the y equals, which is 4x squared minus 16x plus 22. And for the first round, I'm going to plug in a 2. So I'm going to replace all the x's with 2. So 4 times 2 squared minus 16 times 2 plus 22. So again, like I was saying, we're going to have 2 answers. Okay, we're going to have 2 comma something and 3 comma something. We have to find what the something is, the y. All right, so if I solve that and actually evaluate this whole line here, I get y equals 4 times 4 minus 32 plus 22. So I have 16 minus 32 plus 22, which is negative 16 plus 22, so y is 6. I plugged in a 2, I replaced all my x's with 2, my y is 6 at that point, okay? So that's one of the intersections. Now I need to find the other. So I gotta plug in 3 now. So same equation, y equals 4 times 3 squared minus 16 times 3 plus 22. All right, so I get 4 times 9. Negative 16 times 3 is negative 48. And then I have the positive 22. So this makes 36 minus 48 plus 22, which gives me negative 12 plus 22, which is 10. Okay, so going back up here, when x is 3, y is 10, those are the two positions at which they're intersecting. Those are the solutions. 2, 6, 3, 10.